This is Rohini Bawa from Chandigarh Polytechnic College. I'm working here as an assistant professor in Electronics and Communication Engineering department. Today we are going to discuss about the sidebands of AM, FM and PM, which are one and the same thing for these three. So let us start with the sidebands. I'm going to share a PPT with you all so that it will be helpful in your further studies. So, what a sideband is? Sideband is a band of frequencies, which containing the power, which are the lower and higher frequencies of the carrier frequency. Both the sideband contains same information. On the screen, you are able to see about the frequency bands, that is the lower sideband and the upper sideband, and the carrier in between, that is FC. So let us start with the different sidebands. The first one is our double sideband suppressed carrier. In this, the carrier is suppressed and the power saved is distributed to the two sidebands. Such a process is called a double sideband suppressed carrier or simply DSBSC. So we can conclude that from all that figures. So it is a combination of our carrier wave three components, that is a carrier frequency, original one, upper sideband, and the lower sideband frequencies. It is clear that when a carrier is amplitude modulated by a single sine wave, the single signal obtained consists of three frequencies. That is a frequency, carrier frequency, upper sideband frequency, and lower sideband frequency. So we can conclude that the carrier in a standard AM or a double sideband and a full carrier, that is a DSBSC only, FC, full suppressed carrier will be not there, contains no information. This is because the carrier component remains constant in amplitude and frequency irrespective of the modulating signal. Therefore, here the carrier is unbounded. Moreover, the AM power equation states that the ratio of total power to the carrier power is 1 plus m squared by 2, which is equal to 1. So, whereas the other sidebands power remains same. And from we can see that there is no carrier signal at the output. Example, we are going to take like this, that this is for DSBSC signal in the receiver end. Product modulator, the work of product modulator is to modulate or to multiply the local oscillator's frequency, which is known as a carrier frequency, and the signal multiplies that and gives the modulating signal at the output. After that, there is a low pass filter is used, and low pass filter stands for gives us the output of only very low frequencies. So this is about our double sideband suppressed carrier. Here it is a generation of double sideband suppressed carrier. The double sideband suppressed carrier, a modulating signal multiplied by carrier 1 and gives us the sideband suppressed carrier signal. So on screens you are able to see the carrier is suppressed and the sidebands are allowed for the transmission. Now, what are the advantages? The basic advantage is that it provides the 100% modulation efficiency. Due to suppression of carrier, it consumes very less power. It provides a larger bandwidth, and also it provides a very larger bandwidth, and some disadvantages will be there. And it involves a complex detection process. Using this technique, it is sometimes difficult to recover the original signal at the receiver, and it is an expensive technique when it comes to the demodulation of the signal. And in this signal, the phase reversals can take place. A phase shift of 180-degree is observed in some cases. And the transmission bandwidth required by the DSBSC modulation is same as that of the amplitude modulation, that is 2W, that is twice of its width. Now, applications of DSBSC system. During the transmission of binary data, DSBSC system is used in phase shift keying methods. In order to transmit two-channel stereo signals, DSBSC are used in television and FM broadcasting. Now, starting with the vestigial sideband system. In a vestigial sideband modulation, it is a process from where a part of a signal is called vestige is modulated along with the only one sideband. Both of the sidebands are not required in this case for the transmission as it is a waste. But a single band is transmitted leads to the loss of information, hence this technique is avoided. And some major advantages we can see a single sideband are the bandwidth saving and power saving, which enables its expensive use. With the signal, we can say with the use of SSB, some demodulation complications arise at the opposed to the AM system in which carrier is also sent. The larger the bandwidth required by the signal, larger is the spectrum space in this. Spectrum space that is can be saved by transmitting only one sideband instead of both. Ssb is rather well suited for the transmission of voice signals because of every gap that exists in the spectrum of voice, and we can a space that can be saved transmitting one sideband. And transmission of voice signals because of every gap has exist between the signals will be 0 and a few hundred hertz, only a few hundred hertz. In this case, the baseband signal contains significant components at extremely extremely low frequencies, which is used for television and telegraph signals. However, the USB and LSB needs USB and LSB needs at the carrier frequency. The difficulty suggests, we can say, a difficulty suggests the scheme that is a vestigial sideband modulation. One sideband is passed almost completely, whereas just a fraction or vestige of the other sideband is retained. Some transmitted vestige of undesired sideband compensates for the proposed portion of removed from the desired sideband. Now we are going to transmit the signal that occupies a bandwidth of 4.5 megahertz, and in a VSP signal, before transmission, it passes through a filter. So let's start done with the diagram. Going with the diagram that it is a modulating signal provided. Balance modulator. We already know that the water balance modulator can do. Carrier oscillator, it generates the carrier frequency and provides it to balance modulator, which multiplies both the signals and provides a DSBSC signal on the output. After that, a sideband filter, only one sideband will be transmitted after that, and VSB signal will be generated. Then signal is amplified and transmitted by an antenna. So the response of the filter is our sound sidebands, and the frequency of 1 kilohertz is allowed on our different each side of the we can say each side of the sound carrier. Here the sound is transmitted by FM and on a carrier located that is a 4.5 megahertz above the picture carrier. The VSB of the picture carrier is transmitted up to 4 megahertz with attenuation, and thereafter the sideband is attenuated so that it does not interfere with the LSB of the sound carrier. The LSB of the picture carrier is entirely attenuated at 1.25 megahertz. That is, the transmission will be up to 0.75 megahertz, which is without attenuation, and therefore the range that is a 0 to 0.75 megahertz picture is transmitted double sideband over the range of 1.25 megahertz and above, and the intermediate range of the frequency that is 0.75 to 1.25 megahertz, the transmission or the transition is made from one another. The entire transmission is confined to the range of 6 megahertz, which would have required a frequency range of 9 megahertz with a full double sideband transmission. In this case, now starts with the VSP modulation advantages. Following are the advantages of the VSP. First one is it is very highly efficient. Reduction is bandwidth. Filter design is easy, and high accuracy is not needed. The transmission of low frequency components is possible without any difficulty. Possesses good phase characteristics. and it is almost as efficient as SSB due to its reduced bandwidth. I already told you. Because in VSB, a part of lower sideband is allowed to be transmission. It contains on filters is relaxed. Therefore, it is easy to design. The filters can be used in VSB. VSP possesses a very good phase characteristics, which makes the transmission of frequency components is possible. Now, disadvantages. Disadvantages of generation of the VSP, that is first the DSBSC signal. DSP signal has to be generated, which is not a major problem, we can say, but therefore it is generally ignored. And the demodulation process, it is a complex, and bandwidth when compared to the SSB is greater. Now some applications. The most prominent and standard application of VSB is for the transmission of television signals. It is also it is the most convenient and efficient technique, and bandwidth usage is considered in this because the video signals need a larger transmission bandwidth if transmitted using DSBSC system. Therefore, the VSP system is preferred overall and has become a standard for the transmission of TV signals. Now, starting with the SSBSC signals, and it is known as a single sideband suppressed carrier system. In this system, the process of suppressing of one of the sidebands along with the carrier and transmitting a signal, a single sideband called single sideband suppressed carrier system. On the figure, you are able to see on your screens that it is only a single sideband will be transmitted, carrier and sideband are suppressed, and only a single sideband is allowed for the transmission. So here it is a diagram. I'll discuss it later on. First, we are going to discuss that what is a SSB modulation. So it is a major range of bandwidth is wasted in AM and DSBSC, as both require a transmission bandwidth equal to twice the message bandwidth. One half of the transmission bandwidth is occupied by the upper sideband and rest half by lower sideband. We already know that of the modulated wave. Both of the sidebands are related to each other by the virtue of their symmetry about the carrier frequency, with the amplitude and phase spectra of one sideband given to other can be determined. That is, as far as the transmission of information is concerned, only one sideband is necessary. The other sideband and carrier can be eliminated or suppressed, we can say. Therefore, the communication channel requires to provide only the same bandwidth as the base and signal when only one sideband is transmitted. The modulation system is called a single sideband system. Essential function of an SSB modulation system is to translate the spectrum of modulated wave to a new location in the frequency range, and the transmission bandwidth required in this system is one half of that required in AM or DSBSC modulation systems. Let us start with this diagram. And in this diagram, we are having a modulating signal, that is XT, which is provided to the product modulator M1. This method is also known as the phase shift method. And the phase shift method, that in this method, the phase will be shifted to 90 degrees. And by the wideband 90-degree phase shifter. After that, the signal provides to the product modulator M2. Here again, a 90-degree phase shifter signal will be provided, the carrier oscillator, and both the signals get added by the adder. And we got a SSB with a lower upper sideband, only one sideband. So starting with the advantages, I hope this diagram will be easily understandable to you all. Now, starting with the advantages of the single sideband. So in a single sideband, the advantages, the chief advantage we can see in the system is the reduced bandwidth. That is reduced bandwidth requirement. To be more specified, and the bandwidth required in SSBSC is as the that required in a DSBSC system. As only one sideband is used, the effect of selective fading is minimum. In a long-range, high-frequency communication, SSB technique is suitable, and in which the communication has better results. Power required in this system is relatively low, thus increasing the efficiency of the system. So, bandwidth or the spectrum space occupied is lesser than the AM and TSB signals. Transmission of more number of signals is allowed in this. Power is saved. High power signals can be transmitted easily. Less amount of noise will be present, and a fading is less likely to occur. Now, a disadvantage. Generation and detection of the SSB signal is very complex process, and it is quite expensive, and design of circuit is complex. Quality of the signal gets affected unless the SSB transmitter and receiver have excellent frequency stability. Next, it's applications. So we can say SSB is used to the save power in applications where such a power saving is assured. Example, we can say that mobile phone handsets where the weight and power consumption must be kept as low as possible. It also points an extensive use in applications where the bandwidth will be a major concern. Point-to-point communication will be there, mobile communication in land, air and marine, television, radio navigation, amateur radio and military communication, and some prominent users of this system of modulation in form as per their requirement. Here the question arises that why SSP is not used for the broadcasting. This is the major concern of various companies or various persons. So although the SSP systems has a number of advantages over the DSBSC system, but still it's not preferred to use in the system in radio broadcasting applications due to following reasons. So first one is we can say we know that the SSP transmitter and receiver requires an excellent frequency stability, and a small frequency shift in the system will deteriorate the quality of transmitted signal. Therefore, it is not possible to transmit a good quality music effectively using the SSP system. And second one, we can say it's very expensive to design a tunable receiver oscillator with a very high frequency stability due to use of frequency synthesizers. That's why SSB is not used for the broadcasting purpose. So starting with the difference between DSBSC, SSB and VSB. So DSB has a less transmitted power than full AM, and all the transmitted power is useful. Requires a very coherent carrier receiver, and this results in increased complexity of the detector. Suited for it can be suited for point-to-point communication involving one transmitter and one receiver. Then it would be justify the use of increased receiver complexity. In the case of SSB system, a good bandwidth utilization, that is a message signal bandwidth, modulated signal bandwidth, and good power efficiency preferred in long distance transmission of voice signals. Demodulation is harder as compares to full AM. Extractor filter design and coherent demodulation as required. And on the other hand, for the VSP, it offers a compromise between the SSB and DSBSC signals. Bandwidth saving can be significant if modulating signals of large bandwidth, as in TV and wideband data signals. Here, one topic that has remained, which is uh, independent sideband system. That is, independent sideband system. That's areas. Sometimes it will be asked. So, It is the last article in the SSPSC system, or we have to come to know that for a high density point to point communication, multiplex techniques are used. However, for low or medium density, the traffic ISP transmission is employed quite often. We know that in a single sideband transmission, the carrier and one of the sideband is removed for the signal. It is quite possible that the removed sideband is replaced with one another sideband for the information created by modulating a different input signal on the same carrier, which ultimately results in independent sideband transmission. In the case independent sideband transmission, both the original signals have audio range frequencies, whereas in transmitted signal, each signal occupies a different group of frequencies in the spectrum. When it sorry